So, let me introduce to you about geometry. What is geometry? Geometry which is from a Greek word which is geos, it means earth, and metron, it means measure, and it means earth measuring. The Egyptians, the Romans, and the Greeks used geometry in the world of architectural construction. They used it to solve most problems from building construction to astronomy. Euclid, which is the famous Greek mathematician and author of Euclid element and the most influential geometry. Euclid's element is a collection of elementary textbooks with definition and basic geometry principles. There are some basic assumptions called axioms or postulates. The Greeks believed this axiom or postulate was so self-evident that they were true without proof. There are total 13 books. The next major development in geometry in 17th century. The mathematician Wien Descartes developed a way to analyze algebraic equations by using geometry, which is analytic geometry. Lastly, it has been advanced for both practical application and abstract field in 18th century and beyond.
First and foremost, we decided to talk about the Louvre Pyramid as one of the buildings that we can apply the concept of geometry. The Louvre Pyramid is a large glass and metal pyramid surrounded by 3 smaller pyramids in the main courtyard of the Louvre Palace located in Paris. French President François Mitterrand at that time announced the Grand Louvre project in 1981, which included a redesign of the museum and the addition of space. The museum would incorporate the Richelieu wing of the palace, which at the time served as the home of the Ministry of Finance. Ioming Pei was appointed in 1983 to develop a new grand entrance to accommodate the growing number of visitors and to reorganize the museum's interior. The entrance opened in March 1989. When the Grand Louvre project was completed, the exhibition space doubled, with the pyramid acting as the new visitor entrance and offering access to the museum's 3 pavilions. To minimize the impact of the structure, Pei demanded a method of glass production that resulted in clear panes. The pyramid has a total of 673 panes, as confirmed by the Louvre themselves. The pyramid is constructed entirely with glass segments and metal tubes.
Hello everyone, my name is Alia. Okay, now let's move on for the calculation of the Louvre Museum. The Louvre Museum have a square base with length 112 feet, and the height of the museum is 71 feet. By this information, we can find the volume and the surface area of the museum. Okay, let's move on to the next slide where we are going to calculate the volume. Okay, as we already know, the Louvre Museum is in a pyramid shape, so we have to use the formula of pyramid. What is the formula? Okay, it is 1/3 times base area times the height. So just substitute the information given into the formula. okay, which is 1/3 times 112 times 112, which is we can simplify it as 112 square. Then times the height, which is 71 feet. Then just use your calculator to calculate the answer. Then the answer will be 96,875 feet cube. And let's move on to the next slide, which is we are going to calculate the surface area of the museum. For the surface area, the formula is actually quite confusing for me to understand. So let's we understand it together. Okay. The formula for the surface area is the total base areas plus the total lateral face areas. So before we are going to find the lateral face areas, we have to find the slant height. Okay, how to find the slant height? Do you know how to find the slant height? Okay, we can find the slant height by using theorem Pythagoras. Okay, just take one of the triangle side of the pyramid, then divide it into a right triangle. Okay, like this, like the picture that's shown in the slide. Okay, there is the S, that was the slant height, and as we know, the square base length is 112 feet, so divide it by 2, then it will be 56 feet. Then just substitute it into the formula, which is square root of 71 square plus 56 square. Then you will get the slant height 90.4268 feet. Okay. Then when you already got the slant height, you can find the lateral face area. When you got the lateral face area, now you can got the surface area. Okay, now we can find the surface area. Just substitute the base area, which is 112 times 112 feet. Okay, then plus the lateral face area, which is 1/2 times 112 times 90.4268 feet. The pyramid have 4 sides, so we have to multiply the lateral face area by 4. Okay, so it will be 4 times 1/2 times 112 times 90.4268. Now you will got the answer 32,799.64 feet square. Okay, that is all for the calculation of the Louvre Museum. I hope you guys understand, and let's move on to the next part.
This is a nation 56 coins. When negara Malaysia became the sole issuer of currency is Malaysia on 12 June 1967. This was also the same day when the first series of Malaysian coins were issued, including the 50 cents coin. Since 1971, coin were one cent to 50 cents have been minted at the Bank Negara Malaysia Mint at Batu Tiga Shah Alam Selangor. The 50 cents coin is more distinctive than other denominations. The circular shape of the coin has 9 indentations, leaving the original letter Bank Negara Malaysia. The obverse does not feature of 5 horizontal lines. Instead, a relative image security feature is placed on top of the coins, where the denomination letter 15 and cents can be seen when the coin is tilted slightly. In addition to paper money, coins are also the most important element in buying and selling in the market. Usually, coins will be used in purchasing transactions involving amounts of less than 1 ringgit. Next, it is also used as the remaining money that needs to be returned to the customer if the payment may exceed the amount that needs to be paid. Coins are also often used to sell you to their size and weight, which is not suitable for carrying lives. Despite the value of each coin, did you realize that most of them have strip on the side? The strip on the side of the coins were put to prevent criminals from destroying the gold and silver from the coin in the early stage of coinage. The strip on the side of the coin will make it difficult for criminals to do so. However, nowadays, the metal no longer has a high value and it is worthwhile for criminals to make the material for profits. Even so, the strip is still maintained to this day as you can see on every coin. Next, for those who do not have the ability to see, they will use their sense of taste to identify things. The same goes for coins. People with vision problems can distinguish between genuine coin and fake coin by feeling the strip on the side of the coins. The physical characteristic of such coins, however, can facilitate this group and also prevent fraud. The strip found on most coins are not mere fabrication. However, it has certain function that can prevent loss, combat crime, and also help the visual impaired.
So first, we need to find the radius for the 50-cent coin. So the radius for the 50-cent coin is 13.88 millimeter. The first calculation we have to find is area. So the area for the circle is 8 pi r square. The calculation is 22 divided by 7 multiplied by 13.88 square. So the answer is 605.4853 millimeter square. Next, perimeter. The formula for the perimeter is 2 pi r, which is the calculation must be 2 multiplied by 22 divided by 7 multiplied by 13.88. So the answer is must be 87.2457 millimeter. So next, for the value, we use the formula of the cylinder, which is pi r square h. So the calculation is 22 divided by 7 multiplied by 13.88 square multiplied by 2.18, which is the answer is 1319.9579 millimeter cube. Lastly, for the surface area, we use the formula 2 pi r bracket h plus r bracket. So the calculation is 2 multiplied by 22 divided by 7 multiplied by 13.88 multiplied by 2.18 plus 13.88. So the answer is 1401.1662 millimeter square.
Lastly, we go to the conclusion. First, geometry enhances spatial reasoning skill, allowing individuals to understand and manipulate shape, size, and dimension. This skill is crucial in various fields such as architecture, engineering, and computer science. Second, geometry widely used in various real-world applications. Understanding geometry provides a practical foundation for addressing real-life problems.